So remember good old SOHCAHTOA? Let's make sure we can pronounce sine, cosine, and tangent correctly. When you see the abbreviation for sine, S-I-N, it's not sin. You still pronounce it sine, like a road sign. When you see cosine in the abbreviation COS, you say cos, like coast, but without the T. Cos, or like a roller coaster. And then for tangent, when you see tan, you say tan. Last, we have to be able to pronounce this Greek letter of the alphabet, theta. You say TH, and then 8, and then so theta. It's important to know theta because you have to know what angle you're starting at when you are figuring out your opposite, adjacent, and hypotenuse. So let's look at the triangle. Everything's labeled. Hopefully it makes sense to you that the side opposite the 90-degree angle, remember we talked about how it points to it, is the hypotenuse. Instead of writing hypotenuse, we're always just going to write H for it. Now, across from the theta, across from our angle, is the opposite side, and we'll just use O. And then next to the theta is the adjacent side. Now, you may be thinking, well, this side is also next to theta, but that side's already the hypotenuse. So we'll use H, O, and A, and then we'll use SOHCAHTOA so we remember which trig function uses which sides. So if you have the sine trig function uses the opposite side over the hypotenuse, and you'll always write a fraction. If you're using the cosine function, then we're talking about the adjacent side over the hypotenuse. And if you're using the tangent function, T is for tangent, we'll use the opposite side and the adjacent side. So the way this triangle is labeled right now is for theta being this angle. Let's think about how it would be different if theta was this angle up here. Think about that for a second. What would change? If theta was up there, the hypotenuse would still be the hypotenuse, but the opposite side would then be that one, and the adjacent side would then be this one. So always pay attention to which angle is your theta. So let's go ahead and practice in example 1. The first thing I'm going to do is label the sides according to the angle they gave us for theta. I'm always going to start by labeling the hypotenuse first, and it's always across from that right angle, and it's always the longest. So 39 is the hypotenuse. Next, I'll label the side opposite the angle, so that will be O, and then by default, this one's the A. So let's write the function for sine. I know sine is SOH, so we need the opposite on top of the hypotenuse. So we'll write 15 over 39, and if you can reduce, reduce. This reduces to 5 over 13. Next we'll do cosine. For cosine, it's CAH according to SOHCAHTOA, and so we need the adjacent, 36 over the hypotenuse, which is 39. And when we reduce that, we can divide them both by 3. We get 12 over 13. Last, we have tangent. Tangent is TOA, so we need the opposite and the adjacent. So 15 over 36. And that reduces to, you can divide them both by 3. So 5/12. Let's see if you can do 1B on your own. Remember, the first step is to label each of the sides with O, A, and H. All right, hopefully you labeled them like this: H, O, and A. Why are they like that? Because this is the angle we're looking at now. So sine, the answers you should get, check them. Here, I'll put them on and then you can check them. All right, there you go. Here are all the fractions you should get for those answers. Hopefully you did those right. Next, we're going to use our special right triangles, the 45, 45, 90, and the 30, 60, 90, and we're going to find the trig ratios based on those. So first, let's do sine, cosine, and tangent of 30. So we're going to look at the 30-degree angle. It's right here. I'm going to label the h. The side opposite is 1, and the adjacent is the square root of 3. So I'm going to fill all those fractions in. For sine, we know it is SOH, so we need the opposite and the hypotenuse. So it's going to be 1 over 2. For cosine, we need, it's CAH, we need the adjacent and the hypotenuse. So it will be the square root of 3 over 2. Now none of those fractions reduce, so let's keep going. Tangent of theta. Tan is TOA, so we need the opposite and the adjacent. So we need 1 over the square root of 3. That we have to simplify. When we simplify that, we get the square root of 3 over 3. Next row, we're going to do sine, cosine, and tangent of 60. So this time, 60 is going to be the angle we use, which means the hypotenuse is still the hypotenuse, but this time the opposite side is the square root of 3, and the adjacent side is 1. So they flip-flopped. So let's use those to write sine. We need O and H, so it's going to be the square root of 3 over 2. That doesn't reduce. Next, we'll do cosine of 60. We need A and H, so 1 over 2. And last, we need TOA, O and A, so we need square root of 3 over 1. The square root of 3 over 1 is just the square root of 3. Last, we have the 45, 45, 90 triangle. When we look over here, it doesn't really matter which 45 we use, so let's just label H, O, and A. All right, so sine, we need O and H. So that will be 1 over the square root of 2. When we simplify that, we get the square root of 2 over 2. Now cosine of 45. That will be A over H. So 1 over the square root of 2 again, which makes sense because in 45, 45, 90, square root of 2 over 2, the two sides are equal. And last, we need TOA. We need O over A. So it's going to be 1 over 1, which is 1. So let's use those to find the lengths of these special right triangles. We could just use the table and all of the relationships that we were using before, but now we can use SOHCAHTOA. So let's use SOHCAHTOA. We have the 60-degree angle right here. Let's label O, A, and H. Across from the 90 is the H. Across from the 60 is X, that's the opposite side, and A would be over here. All we need to do is find X. So since they gave us this side that we need to find, and since they gave us this side, which is 100, we're going to use the trig function that uses O and H. Which one uses O and H? Sine. Remember, so, because we have O and we have H. So we're going to write sine of our angle, which is 60, equals the opposite side, X, over the hypotenuse, which is 100. Now what we're going to do is we're going to use the table. What's the sine of 60? Well, the sine of 60 is the square root of 3 over 2. So we're going to replace the sine 60 with the square root of 3 over 2. And we'll set it equal to X over 100. Now all we have to do is cross multiply and solve it. 100 times the square root of 3 is 100 square root 3. So we'll divide both sides by 2. And X equals 50 square root 3. Let's see if you can try the next one on your own. First, label the O, A, and H, and then figure out which trig function you need based on what you have, and then solve it. Here's my first hint. I labeled the O, A, and H, and since we need to find O and we have H, we're going to use the sine function. Let's see if you can finish the rest now. Hopefully you did all the work, replaced sine 45 with square root of 2 over 2, cross multiplied, and got 10 square root 2 for your final answer. Alright, let's figure out how to draw pictures for the construction applications. We have a wheelchair ramp from the ground to a deck, and it has a height of 18 inches. Whenever you see the word height, that means how tall something is. So it's an up and down length. So in the picture, that's why we have this up and down line right there is 18 inches. Next it says the angle between the ground and the ramp must be 4.8. So the ground is always a horizontal line on the bottom of your triangle, and it told us that the angle right there is 4.8. Our job is to figure out the distance between the end of the ramp and the deck. So we want to figure out from here all the way over to the deck how far that is. So we're trying to figure out that length right there on the bottom. Well, let's label the right triangle with O, A, and H. Across from the right angle is the hypotenuse. Opposite the angle is the 18, which means adjacent to our angle is the D. The ones we're interested in are this one and this one, so we don't need the hypotenuse. Which trig function does that leave us with? Since we have O and A, we're going to use tangent. Tangent of our angle, which is 4.8. We're going to set it equal to the opposite side, 18, over the adjacent side, which we're trying to find. Now the tangent of 48 we have to type into the calculator. Make sure that your calculator is in degree mode. So if you press the mode button, make sure it says degrees, not radians. So go ahead and type tangent, the tan button of 4.8 on your calculator, and you're going to get 0.0839. Now technically we should round that 9 up to a 4 because, the 39 up to a 4 because the place after the 9 would round it up. So we'll use 0.0840. And we'll set it equal to 18 over D. Now we just need to cross multiply. We can turn that 0.0840 into a fraction. We'll multiply 1 times 18 is 18. 0.0840 times D is 0.0840D. We'll divide by 0.0840 on both sides. And we get D equals about 214.28, or if we just round it, about 214 inches. So that's the answer for how long that distance is right there. The next problem uses this angle of depression and elevation picture right here. So let's see this drawing. We have a park ranger whose eye level is 5 feet above the ground. So this distance right here, he's 5 feet tall. When you look, your eye level is straight out, so that's why they drew this dotted line right here. It says the angle of elevation is 34.6. So normally he'd be looking straight ahead, but the angle of elevation is up 34.6 degrees. It also told us that the ranger is standing 200 feet away from the base. So from here to here, where that ranger is standing, it's 200 feet, so they labeled that. Our job is to figure out the height of the eruption to the nearest foot. So our ultimate goal is to figure out from the top of the eruption to the very bottom, how tall is that? Well, it's going to be this entire distance. We'll use the triangle to find that distance, the x, and then we'll just add on 5 more because he's 5 feet up from the ground for where his eyes are. So let's look at the triangle and label what we have. I have the angle right here. Across from it is the opposite side, so let's just use that circle for the opposite. This is the hypotenuse. This is adjacent. We don't know the hypotenuse, and we don't want to know the hypotenuse, so we have ONA, which means we're going to use TOA, or tangent. Tangent of 34.6 degrees. We're going to put in the opposite side, which is x, put it over the adjacent side, which is 200, and now we will type tangent of 34.6 into the calculator. So that's going to be 0.6898, or 0.6899. We'll set it equal to x over 200, put a 1 under it, and cross multiply. We get 1x, or just x, equals 200 times 0.6898. That's 137.9. We'll round that up to 138, and that tells us how far it is for this part of the triangle, 138. So all we need to do is add on 5, and we'll get about 143 feet tall for the height of Old Faithful.